Today we're looking at section 4.1, and it's called Understanding Polynomial Expressions. Before we learn how to add and subtract polynomial expressions, let's look at the definition of what a polynomial is. Let's start off with the definition of a monomial. The word mono means one, so one expression. A monomial can be any number. That includes decimals, whole numbers, fractions, negative numbers, positive numbers. If it's a number, it's a monomial. It can also be a variable. X, Y, Z, any letter in the alphabet will work. Or a product of numbers and variables that have whole number exponents. Let me stop right there. So keep in mind, I said that a monomial has to be a product of numbers and variables. Okay, so if you're multiplying a bunch of numbers and variables together, the product of all those combined is considered a monomial. Another important feature is that the exponents need to be whole numbers. If the exponent's not a whole number, then it's not a monomial. Now let me take you back to elementary school. A whole number, and I'm going to write it right here, a whole number is any number, any positive whole number, including 0. So 0, 1, 2, 3, 4. Those are all examples of whole numbers. 4.5 would not be a whole number because of the half. Now that I've cleared that up, let's look at a few examples of what these monomials are. So if you look at the left column, we have the number 4. 4 is a monomial, and so is x. 4 is a number, x is a variable. Now, if we wanted to multiply a number and a variable, that's perfectly fine. Because in the definition, it states that the product of numbers and variables are also monomials. So, for example, negative 4x, y. Now, I know you don't see the exponents surrounding x and y, but I promise you the exponents are there. If you don't see an exponent, the exponent in that variable is automatically 1. So x is the same thing as saying x to the first power. That y is the same thing as saying as y to the first power. A few more examples of monomials would be 0.25 x to the third. We have the 0.25, which is a number, and we have x to the third. Notice how the exponent is a positive whole number. Remember how we talked about that at the beginning? Okay, 3 is a positive whole number, which is completely okay. The 0.25 is a number. Let's look at the next one. xy divided by 4. So, although this doesn't look like a monomial, we can rewrite x times y over 4 as, we can rewrite that as 1/4 times xy. Well, what's 1/4? 1/4 is also a quarter. So 0.25 times xy. Yes, we have 3 characters, but remember, we're multiplying all 3 characters together, which makes it okay. It's a monomial. Now let's look at some examples of non-monomials. The first expression I want to look at is 4 plus x. This is an example of a binomial. A binomial is when you add two monomials together. For instance, 4 is a monomial, and so is x. Because we're adding them together, we have what's called a binomial. Another example of a binomial is x minus 1. X is a monomial, and so is 1. And because we're subtracting them, and we have two monomials, x minus 1 is a binomial. In our next expression, we have 0.7 times x to the negative 2. Now, I know what you're thinking. 0.7 times x to the negative 2 looks like it could be a monomial. Unfortunately, though, if you look at the exponent is a negative number. And because it's negative, 0.7 times x to the negative 2 is not a monomial. In our next expression, we have y divided by x to the third power. And once again, this looks like a monomial, but unfortunately it's not, because we can rewrite y divided by x to the third as y times x to the negative 3. And there's that negative exponent. Once again, because the exponent's negative, y over x to the third is not a monomial. And finally, 0.25 times x to the negative 1. Can you guess as to why this is not a monomial? That's correct. The negative exponent tells us that it's not a monomial. Now I want to teach you how to name a polynomial given two things. 1, you're going to need to identify the number of terms. 2, you need to identify the degree of the polynomial. Let's start with identifying a polynomial given the number of terms. So if a polynomial has one term, it's called a monomial. Remember, mono means one. Mono, one. So for example, 5, x, y, 5x. These are all examples of monomials. Now when you add or subtract two monomials together, you end up with a binomial. Take for example 5 and x. So we can add 5 and x. 5 plus x makes a binomial. So will 5 minus x. And we can even go on to say 5 plus y is also an example of a binomial. Now if we combine 3 monomials together, we have what's called a trinomial. Tri means 3. Some examples of a trinomial would be something like x squared, which is a monomial, plus 5x, which is another monomial, plus 6, another monomial. So notice how we have 3 monomials, which makes this example a trinomial. Now, if a polynomial has 4 or more terms, we have what's called a polynomial. Now I'm going to teach you how to name a polynomial based off of its degree. If the degree of the polynomial is 0, then you have what's called a constant. Usually constants are just regular numbers. 5 would be considered a constant, 3, 2, 0, -1. If it's a number, then it's a constant. If the degree of the polynomial is 1, then we have what's called a linear polynomial. Well, how do you exactly identify what the degree is? It all depends on what the largest exponent is. For instance, If I have 5x, the largest exponent in this monomial is a 1. Therefore, the degree of the polynomial, or the monomial in this case, is 1. Therefore, this is linear. If the degree of the polynomial is 2, then it's called quadratic. For example, 5x to the second power. Notice how the exponent is 2. Therefore, this expression is quadratic. If I had 5x to the third, then my expression would now be a cubic polynomial. Why? Well, the degree of that monomial is 3. If the degree of the monomial or polynomial is 4, then we have what's called a quartic polynomial. Explain 2a. We want to write each polynomial in standard form, name the polynomial, then give the leading coefficient. We have 20x minus 4x to the third plus 1 minus 2x squared. To rewrite this in standard form, we want to rearrange the terms so that the exponents are in descending order. Let's start off with negative 4x to the third, since it has the biggest exponent, followed by negative 2x squared, since the exponent is 2, followed by 20x, so add the 20x because it's positive, followed by 1, since 1 doesn't have a variable. Okay, so we rewrote the polynomial in standard form. We've satisfied part A. Now we need to name the polynomial. How do you name a polynomial? It all depends on two things: the number of terms that make up the expression and the degree of the polynomial. The degree is going to be the largest exponent in the polynomial. Let's go ahead and identify the number of terms. We have 1, 2, 3, 4. Your terms are separated by plus and minus signs. We have 4 terms. In regards to the degree, let's go ahead and identify the largest exponent. The largest exponent is 3. A polynomial with a degree of 3 is called a cubic polynomial. And if it has 4 terms, then it's a polynomial. Oops. Polynomial. Which means that the name of this polynomial is a cubic polynomial. So you want to start off with the degree followed by the name of the term. Now let's look at part C. In part C, we want to identify the leading coefficient. Well, we know the word lead means leader, right? It leads the group. So it's the number that leads the entire polynomial. The number that leads the entire polynomial would be negative 4. So our leading coefficient is negative 4. LCF, leading coefficient, negative 4. Explain 2b. Write the polynomial in standard form, name the polynomial, then give the leading coefficient. To rewrite it in standard form, keep in mind that we have to rearrange the terms so that the exponents are in descending order. So if you look at the terms, the term with the biggest exponent is going to be that negative z to the 6th power. Okay, followed by z to the third, followed by the 4z. So part A is done. Moving on to part B, name the polynomial. Once again, we need two things. We need to identify the number of terms, followed by the degree. If you look at the expression, you can see that we have three terms, 1, 2, 3. And those terms are separated by the plus signs. Now let's look at the degree. The degree is going to be your biggest exponent, and the biggest exponent is a 6. Now let's go ahead and name the polynomial. We know that the number of terms is 3, which means that this is a trinomial. But the degree is 6. We haven't gone over that. The highest we went to was a degree of 4, and a degree of 4 would be quartic. So we're just going to stick to the fact that the degree of the polynomial is 6. And as a result, we're going to name this polynomial as a trinomial with a degree of 6. Now let's move on to part C. Let's give the leading coefficient. We have negative z to the 6 plus z to the third plus 4z. The leading coefficient is going to be the number that's in front of the negative z to the 6. And as you can see, there is no number in front of it. That's because that number is imaginary. We have the negative in the front. Okay, and if you don't see a number, go ahead and put the number 1 next to the variable. So in other words, negative 1, z to the 6 plus z to the third plus 4z. And as you can see, that leading coefficient is negative 1. By the polynomial by its degree and the number of terms. Notice how with this expression we have two variables. Let's start off with identifying the number of terms. So we know that the terms are separated by the plus signs. Here are our plus signs. And as a result, we have 1, 2, 3 terms. Now let's identify the degree. This is the tricky part. So what you do is you have to look at each monomial. And because we have two variables in each monomial, we have to find the sum of the exponents for each one. For instance, we have 3x squared y squared. Go ahead and add the two exponents. So we know 2 plus 2 is 4. So the degree of this monomial is 4. Now let's look at our second monomial. In our second monomial, the degree is, well, let's go ahead and add up the exponents. We know that x has an exponent of 1 and y has an exponent of 2. So if we add those two together, 1 plus 2 makes 3. And finally, in our last monomial, we have 5 times xy. That x is going to have an imaginary exponent of 1, and the y is also going to have an exponent of 1. Now, if you add those together, you end up with 2. This monomial has a degree of 2. The biggest degree is 4, which means that the degree of the polynomial is 4. If the polynomial has a degree of 4, it's called quartic. And if it has 3 terms, then it's called a trinomial. So the name of this polynomial is a quartic trinomial. Let's go ahead and quickly do problem B. We know that we have two terms. And as for the degree, let's go ahead and find the degree of each monomial, and then from there, identify the biggest one. So A has an exponent of 1, and B has an exponent of 2. The degree of this monomial is 1 plus 2 is 3. Now let's move on to the second monomial. A has a degree of 2, whereas B has a degree of 1. So 2 plus 1 is 3. So notice how both of the degrees are exactly the same. So since the degree of each monomial is 3, let's go ahead and make the degree of this polynomial 3. Now let's name the polynomial. Number of terms is 2. Forgot to write that down earlier. If it has 2 terms, it's called a binomial. And if the degree is 3, it's called cubic. So this is a cubic binomial.